Hi, and welcome here to the session about rethinking validation. My name is Jan. I'm from Germany, from ASAP, which is part of HCLTech, and I joined ASAP about 6 years ago in the department of virtual validation. So you can see the title here, how to validate software in an evolving automotive landscape. Well, actually, it was 2 years ago when we said, hey, let's rethink validation. You all know these problems. You're having some tools somewhere, you're having your requirements somewhere, you're having your test systems, and then someone is coming to you and saying, hey, here's a test report. But what does this say to you? And how is it really connected to your requirements back? And if you're approving software, how can you be sure it's safe? And actually, all of this data, which is lying somewhere, is there, but not really connected. So we said, hey, let's make life easier. Let's connect it. Let's make it traceable. And with that, we want to change the life of our test designers, the life of our developers, to make it like more software-driven and more parallel to the development process, and also of the test managers to be sure what they want to approve and what they can bring to the management for approval. So we're having some challenges and opportunities, which you all know. Everybody says, hey, reduce the time to market. We have to be ready in like months and not like years like before. It shouldn't take like 3 years to bring a new vehicle to the road. It should be like, in best case, about half a year to make the next product increment. And we're also saying, hey, where's my traceability? And for the traceability, I needed to have a really good safety feature where I can be sure that everything is working properly. And well, virtualization, that's also a topic. Bringing it more to the left side, make it more software-based, make it cheaper, and be earlier in the development process. And at the end, our solution is a end-to-end validation ecosystem, which we are presenting you today. So, well, we call it TestSphere. TestSphere is a solution which directly brings your requirements, which you're, for example, having Codebeamer, Polarion, or Co., what I mentioned before, into a world where everything is connected. You're having your systems architecture, which you're bringing in. And you're also having AI, which supports you in the whole development process, because it gives you proposals on how you could make your test design. And all that in a secure environment. That means no data breaches anymore, because the AI is based in your system and you have full control of that AI system. And on the right side, we can see our test systems. And in that test system, we'll find a SIL, a HIL, a vehicle testing, which we are just feeding in with unified test cases, which can be used in every test layer again and again without any major changes. So we've rethought the whole system. We thought, hey, let's make a new universe. And that's what we did here. We have built TestSphere, which are having a lot of spheres, which are going around your existing tools. And that's improving your quality and is also making life easier. To give you some numbers there, with TestSphere, we reached our goal to save about 75% of our test design time. That means, well, you don't have to write the same test case again and again. You can use existing fragments. We're talking about a fully automated test implementation. So there's no manual step left for that test implementation, and everything is automated. By keyword-driven testing, you can fix errors once by just fixing them in keywords and not going to every test case again and again, make a find and replace, and don't be sure on how it changed. It's a generic approach in here. All data in one place. And the best thing is, if you're having a tester, he doesn't need to be an expert in your test system or in Codebeamer or every other tool. He just needs to understand keyword-driven testing and can write that test case in an interactive editor. So that's the base idea behind that. So I mentioned keyword-driven testing, but what's keyword-driven testing? Keyword-driven testing bases on the ISO 29119-5. And well, it's not that new. It's about, I would say, 7 to 8 years old. And we've taken that concept and brought it to a real world. It means you're having like composite and simple keywords, and a composite keyword would be like a standard instruction set. So now you would write, initialize my car, and not set these 10 signals to these values. This is done via these compositions. That makes life a lot easier compared to a conventional testing. And to give you a feeling on there, we're having here a test case, which is a conventional test case for a full vehicle testing. If you make it conventional, it has like 403 lines to write that test case. It's a cruise control which you're activating and where you're getting some HMI feedback in there on your test system. If you write it with keyword-driven testing, that same test case is just 16 lines to write. So I think you can't make a lot of errors in 60 lines compared to 403 lines, just from my own experience. So as I said, you're saving like 75% of time, and that's an idea of reusing your instruction sets you have already written in other test cases and don't write it again and again. So AI. Well, we thought, how could we include AI in our concepts? Most of the cases we say, hey, AI solved the problem for me. And we thought, that can't be the solution. So we decided to go a generic approach first. That's what we have seen in keyword-driven testing. And we decided we're having just one manual step. That's the test design step. And what we could do is we could use our large language model to propose test cases out of our requirements based on the history of what we did before. And that's what we're doing here. So we're having here our large language model. We're having a RAGDB, where we're having our context, which we are feeding in. And actually then we're also having a validation stage to check if our RAG data is really usable for our results or if it's messing it up. We're also having like an automated trace analysis with AI. So it will also give you some anomalies and give you the info what was wrong in your test execution. We're having a tool which is called Automate, which will give you a hint on how you could improve your requirements. That means, how could you write it better, or perhaps the requirement is already existing. And actually some basic features like autofill, or we rethought our help bar in TestSphere. We are using our large language model to give the user an information what he could do in the next step based on his context, what he has done before, and based on the page where he is with all the source code in the back end to really have the full information for a large language model to give you hints in there. So now I talked about TestSphere. I talked about how we can improve testing at all. So the idea how we can make life of our testers easier. But actually that's not all. You should also rethink about how we can improve the validation process as it is. So how we can make a modular and scalable software in the loop system where we're not tightly coupled to some specific tools, where we could reuse our stuff to have done. And that's also what we did. So we rethought a whole SIL system. In our SIL system, we're having like 3 to 4 main components. The first component is the simulation core, which you can see on the left. The simulation core, you'll find all the environment simulation. And that data is transferred via the so-called open simulation interface to the interface provider. And the interface provider is making a mapping between your OC, your simulation data, to the Ethernet, CAN, and FlexRay interface. And with that, we're reaching a decoupling that you can just further develop the simulation core, and you don't need to be an expert in the VECUs if you're developing a simulation core. So we are, again, separating the different topics in a SIL system, make it easy to develop the whole SIL system further, and also to reuse it in different systems. And as a center middleware, we are using ROS, and as a test framework, the robot framework, and all that on the base idea of getting an open source solution. All that is also running in AWS. You can see our interface definition on here. We're having Kala on a AWS machine with Windows, and we are having the rest in a containerized solution on a AWS machine with Linux. So that's how it's running there. The base idea of that system is a mix and matched system. I brought you 3 different examples. So in the first case, we want to make it cost efficient. So we could just change our simulation core to Kala and say, oh, okay, it doesn't need any further license costs at the moment, and we are taking ROS2 as a middleware. But in some cases, that's not sufficient. You want high fidelity vehicle dynamics. Then Kala isn't the best choice, therefore. And we would also choose a more deterministic middleware. So in that case, we can just change inside the simulation core everything to CarMaker. And we can just retake the rest of the simulation core, all that control, health monitoring and stuff, and reuse that. And the middleware ADS2 just connects again to our simulation core. And the interface provided in VSU stays the same, because it's decoupled from our environment simulation. And the last point is a car-to-X system, which I'm bringing to you. Here's the idea to have a really fast and efficient simulation, because we don't need any specific vehicle dynamics. We'll need a lot of actors which are communicating to each other, and we want to improve the performance on that point. Here we're using Sumo, and they could use a middleware, DDS, or whatever else would you choose. And that's the base idea. You you make it just based on your needs, and you take everything again, which is already there, and don't rethink the whole world for a test system again and again. So what I've shown to you is all running on AWS. So I've brought you an image on there on how it looks on AWS. So we had the big challenge to get a connection between our local system, which is running at HCL, and we're having our AWS system. So we're having some services which are hosted at HCL, for example, Codebeamer or a Bitbucket. And then we're having our AWS system, where we're running the TestSphere, which I've shown to you, where we're having also a container registry, a Jenkins-like solution, and a code build. And then we want to spawn out machines, test systems, out of TestSphere. And there we're having the need, it has to run on AWS, but it also has to run on our customer side. So with that connection here, with these VPCs, where we're also having these gates, these are 40 gates, we are now able to execute a test bench from TestSphere, which is running in AWS, on the customer system, on our local system, and also in the cloud. And that means really scaling it up, and that's scalability. So I've shown it to you before. That is our structure. The base idea of everything is, let's make it modular. So I also want to have a short look with you on the build process. We can see we have taken that system and separated it up. We're having different containers. And with these, we are now able to automatically generate images, which you can see here with Packer. And we can create an image for every part, for like a Docker container, a virtual machine, or for example, for your virtual box, which is running on your system. It's all unified, it's all reusable, and these are recipes, which are really generic. So that makes life for developers really easy. And then Jenkins, for example, just deploys these containers into the cloud, in that case AWS, and it directly runs it because we're using a middleware which is able to use a cluster. We can separate it to different machines and really improve the performance of the system. So now we have talked about, hey, how does it look like when we are having the whole system? We rethought a bit of validation. And we have seen TestSphere, an idea on how we can make a unified ecosystem for testing. But actually, what you can take with you in that point, what's an easy change you could make in your system? And we brought you 5 points, 5 columns of efficient testing. The 5 points we did in the first position, in the first possible point to improve our testing process. The first one is a generic test design. That saves you a lot of time. Make your test cases reusable. Use something like keyword-driven testing, or use any methodology which is machine readable, which uses these functions, and where you don't have to write it again and again. And with that, finding bugs is getting a lot easier, and fixing them also. The second one is, we're always talking about a fully automated test solution. So if it's not fully automated, it's not ready. Let's be serious. Anything where a user needs some manual input can be automated. And that's what you should do. There should be one manual input at the beginning, but not during the whole process, because that's holding up your time. And actually, that's not what a ready software product should look like. The third one is, you should optimize the test process. Just rethink, what could you test in a virtual world? What really needs to be tested on the car? Testing in the vehicle is really expensive and on hardware. So shift it to the left, make it to a virtual validation. The fourth is, talk about traceability. Get 100% traceability. If you're having the traceability, it really pays out for you, because you know what you changed, you know what didn't happen. If you don't have the traceability, you're just guessing what changed, and you're just guessing if your software is working properly. And that's a really, really huge issue. And the last one, and the most important one for me, is only test the changed and impacted. It doesn't make sense to test everything again and again. You will need a good architecture. You will need the right tools to view anything. You will need, again, the traceability to see what really changed, and that saves you time. And well, actually, you don't need to test it again and again if nothing changed. And that's really important here. And that's what we did to rethink validation. And to give you one more feeling about that, what I'm showing you today is not just a proof of concept. It's not just a crazy idea. It's something we created 2 years ago, and something we already implemented with some of our customers, which really revolutionized their testing process. So thank you very much for your time. And I also want to thank you that you're all here.